on, turn on.
I'll sleep on the library for 2 hours.
I know that feeling. I know that feeling. Come on! What is wrong with this? On! On, on. Up, up. She wants to get a better EAP score. And you want a better EAP score. So you must practice your English.
Oh, I'm fine.
Good man. There we go. There we go.
Times 364.
Implicit derivative. Be strong. Got pen and paper?
It's 2 hours just like this. I didn't move. Did I miss any math class before this?
I don't think so. Did
I
she?
remember.
Did she miss last? We did product quotient and do we do chain rule?
Yeah, the last class is chain rule.
Last class was chain rule. Yeah, so that's fine. Okay. Here's the problem. We know, for example, the derivative of x squared, that's equal to 2x. But the derivative of y squared, that's not equal to 2y. Okay? I'll give you an example. So for example, y. Let's say that y equals 2x cubed. Then y squared would equal 4x6. So that means the derivative of y squared would equal 24x5. And this does not equal 4x cubed, which is what the 2y would be. So in other words, I'm trying to show you that y squared does not become 2y. So now, why? Well, this is the problem. You see, this one is okay because this matches this. That's why it's okay. This one is not okay because they don't match. So, the way to fix it is very, very easy. Can I scroll down? I don't think there's anything here. So, for example, if I want the derivative of some function, but it has y in it, not x, I can say that's equal to 1 times d dx fy. That's equal to dy dy d dx fy. I can swap these. So that's equal to dy dx d dy fy. So that's equal to dy dx times derivative of y. So what does that mean? So it means this. If I want the derivative of y squared, the answer is 2y, but you must multiply by dy dx. So the rule is, if you want the derivative here, you just say it's dy dx times the normal derivative here, the usual derivative here. So when you differentiate by y, you multiply your answer by dy dx. When you differentiate a y term, you multiply by dy dx. So here's another example. Tell me, guys, what the derivative of sine y is. What would that be? That'd be cos y times dy dx.
Dy dx is
Example, derivative of ey, what would that be? That'd be ey times dy dx.
what is dy dx?
We don't know.
Okay.
We don't know.
Oh,
Yeah.
okay.
But I'll do an example now. Watch this example. So take this example. X squared plus y squared equals 1.
Yeah.
We want dy dx.
Oh.
So what you could do is change this into y equals root 1 minus x squared. But that's okay. But what you could also do is differentiate, differentiate, differentiate. So x squared, that becomes 2x. Y squared, that becomes 2y dy dx. And 1, what does that become? 0. So you get your answer. Dy dx equals minus x over y. See? Now this method is very good for hard problems like this. Let's say x squared plus x plus y squared equals 0. Okay, so I have 1, 2, 3, 4 examples. Here's the 5th example. I'll just make a bit of space here. Maybe you guys can tell me what to do here. So what does x squared become? 2x. And x?
1.
And y? 1 dy dx. And y squared? 2y dy dx equals 0. So you can get here dy dx equals minus 2x minus 1 over 1 plus 2y. If you rearrange it.
Oh, so that rule usually, what's the question asked?
So usually the question is just find
dy
dy dx, yeah.
Oh.
Okay.
That's all. So this is called an implicit derivative because, look, your answer has x and y in it. X and y.
Yes.
Yeah. Okay. We'll do some more examples. Maybe you want to write this down first. Sorry, the board is a bit messy. Ooh. Look at this mess.
Today, Kalima's the topic is wave energy.
He did the presentation?
Yeah.
So where is he? He did wave energy.
Yeah, and that's what we learned recently. I got shocked. Genius.
What did you do? Baseball. And what did you do?
Speech and
Did they ask you a question at the end?
Yeah.
What was your question?
They said, the colonel asked me what's.
Oh no, you had Connell.
Yeah.
Oh, that's terrible. What did he ask you?
Colonel asked me, what's the difference between the baseball and another ball?
Oh, Connell. Oh.
And the first I didn't search anything in my brain.
Yeah.
Okay? And I said, the common things is if the ball. I say what's the common thing is. I say if the ball like throw the area, whatever the ball, the timetable or something, they will have the air friction, that kind of force. But I can't find what's the difference. But after the presentation, I saw I should say it depends on the material of the ball. But I can't find at that time it was.
Connell asked hard questions. What did you get asked?
he asks, what is positive of oxidation?
Oh, like the benefits.
benefit.
Is there any benefits?
Yeah, I think it's really tough
Yes.
question actually. I can't, if I'm doing this presentation, I can't find it. Because oxidation,
It's a bad thing, isn't it? Like rust.
yeah, rust, and usually he gave the example like apples, if you put long
Yeah,
time.
yeah, rots.
But I mean I answer is like color change like tea.
Ah, very smart.
But I don't think it's benefit, but I search they say due to
Doesn't matter. Connell won't know. Good answer. Good answer.
Neil asked me tough question I think. But Neil asked him like why you choose this presentation? Why you choose this topic?
for me this question. I just
What? Yeah. Why did you choose it?
I don't have to answer.
Why did you choose yours? I know why you chose yours. It's easier.
Yeah, and lots of benefit. Because in the introduction, I say like lots of a few ball players have the degree on mathematics, but everyone needs a practice mathematician on the field. So I say like blah blah blah, and Neil asked me, do you think if baseball player they don't know anything about baseball, is that possible? Like kind of this question. I don't think that's easy as well.
He's tough. He's tough. Okay, you got that? So, I'm going to give you a hard one to try. Let me see if you can get this one. So, find dy dx if x squared plus xy plus y squared equals 3.
Do we have any action in the tomorrow big six class?
I don't think so. I think we just want to work on the maths coursework.
Oh,
Yeah.
oh, it's fine. No. Okay.
Yeah?
Very sorry.
I said you could upload your essay soon. Wasn't it? If it's finished.
No. Oh.
Okay.
Wait a second.
Okay. Yeah. So what? Did you get it, go?
Yeah, that's the last one.
Yeah. So this is 2x. Okay. Now here
Why?
you need the product rule. So it's 1y plus x1 dy dx plus 2y dy dx equals 0. Yeah, product rule.
It's
0.
X.
At 0.
Oh, I got the
Yeah.
X.
Sad.
Yeah.
So dy dx equals minus 2x minus y over x plus 2y.
Yes.
Yeah.
Got the X.
Okay, next question now. That's part A. Part B is find the tangent line at x equal 1, y equal 1. So this will have some shape to it. I want the tangent line at 1, 1.
Tangent.
Tangent, you know tangent? You know tangent, Ben. Tangent.
So what is the function?
The same.
Same question.
Same question, yeah.
Tangent.
You remember tangent?
Something.
It's something, yeah.
You got right angle.
That,
Like this.
yeah, no, I don't need the normal, just the tangent.
It's a line.
It's a line, yeah, correct. Think you know what to do then?
I'm confused. Is that why inside dy dx is the same as yt is y?
So, here, y equals mx plus c, yeah? Y equals minus 1, because you just put in 1, 1. Yeah? So that's minus x plus c, and then you put in 1, 1. So you get c then must be 2. So the answer is minus x plus 2.
Where's I'll put 1 in. I took it too difficult.
You did. You did. Maybe you should write this example down.
That is the slope.
Slope.
Yeah, of course. Yeah? You wrote that down?
Mm.
Yeah. Okay. Now, one thing that's useful with implicit derivatives is questions like this. If I say y equals 2x and I ask you, what's dy dx? Do you know the answer to this question? Do you know what the derivative is?
I think
Yeah. Yeah.
we use this way.
Yeah, we can use implicit derivatives. So watch carefully.
X minus 1.
Not x minus 1 actually. Watch what I'll do. First, I'll put log on both sides. Yeah? Okay? So then that's log y equals log 2 times x. Now I differentiate. So this becomes 1 over y dy dx. What does this become? What's this going to become?
What's going to come from? So half.
No.
So it's
What's the derivative of 4x?
4.
What's the derivative of 0.9x?
2 point. Okay.
But L and Y becomes 1 over Y times dy dx.
Implicit. The rule we had today. Well, I'm differentiating.
Oh yes.
Yeah?
Yes. You means the left and right.
Correct, yeah. So dy dx equals y log 2. So now I have my answer. My answer is equal to 2x log 2. Yeah? What do you think? Is it okay or is it not okay? Is it okay? Maybe you should write it down.
The answer is what
2x log 2.
I means was equal to x log 2.
Oh, the derivative.
Just dy dx.
Yeah.
But you know the dy dx equals y log 2.
Yeah.
And equals the
And y is log 2, is 2x.
oh.
Yeah? Okay? Okay. Right. Let's do a hard one. A hard one. Y equals sine inverse x. What's dy dx? Be strong. is not cos inverse. Let's see. So first, I'll change this into sine y equal to x. Is that okay? Yes? Ben?
Yes.
And what's the derivative now? Derivative. So sine y
Cosine y multiplied
equals 1. So dy dx equals 1 over cos y. So that's equal to 1 over cos sine inverse x. Now we want to simplify this, yes? So I draw my triangle. Sine is opposite over hypotenuse. So this side is root 1 minus x squared. So what's cos? Cos is this over 1. So the answer is 1 over root 1 minus x squared. See, I told you it's a hard one.
I understand the triangle thing.
Yeah, so look, here's sine inverse.
Yeah.
And sine is opposite over hypotenuse. Opposite over hypotenuse.
Okay. Sure.
But we don't want sine, we want cos. So cos is adjacent over hypotenuse. So it's like this over 1. This is the cos. I tell you what page this is like. If you look at page, the bottom of page, oh come on, the bottom of page 58. The last question on page 58.
Are they simple?
Yeah. Do you remember doing these?
Are we doing this?
Did you do this?
It seems like only started 4.
Bad teacher. You don't remember doing 5?
It's
That-
really clean here.
Too clean. Who was your maths teacher? Joan?
No, maybe it's my fault. Maybe I fall asleep.
Do you remember doing that, Ben?
No.
Okay. Do you need a little help on it?
I think so.
Yeah. So, for example, I'll do the first one as an example there. So if you have sine cos, oh, go. Terrible. Right, so as an example, Ben, sine cos inverse 4 over 5. Now, look, if I type in sine inverse a number, I get an angle. So like for example, sine inverse, whatever, 0.5 is 60 degrees, isn't it? Whatever, okay? If I type in sine a number, I get a ratio. Like for example, 3 over 5. You know, or like for example, sine 45 degrees equals 1 over root 2. Okay. So, cos inverse 4 over 5, is that an angle or is it a ratio?
Angle.
This is an angle. And then I want the sine of this angle, so altogether
Ratio.
it's a ratio. Okay? This angle here is from this triangle. 4, 5. This here, that's cos inverse 4 over 5. I want the sine of this angle. So I want the sine of this, which will be that side over that side. So Pythagoras says this is 3. So the answer here is 3 over 5.
number like 5, 13, and 4 and 5. 5, 13, 5, 13.
I know what I'm doing. The last one, for example, let's say sine cos inverse x. Okay? Let's draw the triangle. This side is x. What's this side? 1. Because it's like x over 1. This side, root. So what does this equal?
Just
Root 1 minus x squared. So for example, sine cos inverse whatever 0.1 should equal 1 minus 0.1 squared.
Okay.
Okay? Yeah? Are we okay with these now, do we think? Is it? I'll tell you what I want you to try now for me. Not this page. Implicit. Good. Okay. So could you try 2 n? Yeah, the last one, 2n. Sorry. 3l 4 7 12 CD.
We're choosing the longest one in the question.
I am. Because I know you are strong. Yeah? Let's see how you do.